Hello guys, welcome back to my live stream. Today we will continue our project that is campus recruitment prediction. Yesterday in live stream, uh, due to some uh, uh, audio failure, my audio was corrupted, or you can say I do. So today I will give you a quick recap what we have done yet. So initially we imported our necessary libraries like NumPy, Pandas, Matplotlib, and Seaborn, and then imported our CSV files like train CSV using sorry using pandas.read CSV. Then we see wait a minute. Let me run this. So then we see what's the shape of our data frame, and then we see what's inside this data frame, what are columns in this data frame. So we see there is serial number, gender, SSCP, SSCB, HSCB, PHSCB, HSCS, and degree P, degree T, work experience, E-test P, specialization, MBA P, and status and salary. So serial number is serial number like 123. Gender is 0 and 1, and you can say 0 is for male or female. We don't know. And for SSCP, it is a percentage in our secondary school, and B stands for here board. What's the board like? It is central board or another board. And HSC means high school. HSCP means high school percentage, and HSCB means high school board. It is other board or central board. And also we have HSCS, which stand for what's the stream in our high school, like arts, commerce, and science. And here degree P. Degree P means what are the percentage he or she got in his degree or in graduation. Degree T stands for what's the you can say same like stream like science and technology, commerce and management, I guess, communication and management. Work X is stand for work experience. Is he has prior work experience or not? E-test P means sorry, I don't know about that, but it can be a kind of entrance test for, and this is the score of that entrance test. And specialization. Specialization is like marketing and HR, or marketing and finance. MBA means percentage uh, MBA, and status is placed or not placed. Like uh, he uh, uh, he got or you can say a job. He got placement or not. And salary means salary stand for how much salary it has he or she got. And then we hit, let me again, now let me run df.info. So we see here that these are all object types. Okay, now we know we do not need serial number column is just useless for us. So we drop this from data set, and for that we use df.drop. After drop we have to use our write our column name, and then we have to give which axis on which axis. Like if we have to remove the row, then we have to type x is equal to 0, and if we have to remove column, it is column, then we have to write x is equal to 1. Using in place is equal to true. it will change this in df folder. We do not have to save this in another folder. Oh, yeah, another data frame, sorry. Okay, we run this command, call, and this is now we are checking for null counts. Is there any null values in our data frame? So we see we have 67 null values. Also, okay, first we will see if there are any duplicate values. So we are trying to drop this duplicate value, and again we are using a dot drop function for this, and typing in place is equal to true means if we have there is any duplicate value, we have to drop this from data frame and save that data frame in df as it is, not in other data frame. Okay, so again we type df.shape. So we can see here shape is 215, and before here it is 215, so there is no duplicate value. Okay, now we will see what's the salary, mean value for salary and median value for salary, because we can see there is 67 null values in salary column. So before that we will draw a visualization. We will see is the status correlated with salary, like person who placed what's their salary, and who not who not get placement what's their salary count. For that we draw a histogram. Here axis is equal to data frame of salary and means equal to 40, and also we draw here we use a df or df of status dot value counts for finding what's the value count of placed or not placed. If you can see here, not placed is equal to 67, and we also know that our salary column has 67 n values. So we can say, also we can say see from here in which here it is not placed, it is nan. Or we can do one more thing, we can here df dot head for 10 values, and here you can see like it is, if it is not placed then salary value is nan. Here also, so if he got not placement, so we have to fill nan values with 0 because he do not get placement. So we are filling nan value with 0 in salary column. Okay, now we are checking our null counts. So here you can see there is no null values, and for finding null counts we use df dot is null dot sum. If we do not use sum, then it will give us a uh, array of 21 215 cross 14 array. Let's see, here you can see we got 215 cross 14 array, and for summarizing it we have to use sum, and here we get our results. Now our aim is to find the unique values, unique values in object data type data type columns. So for we created a column called object. We initialized, or you can say defined, a empty list with name obj, and we created a for loop for call in df dot columns. So we take all df columns and we give a condition if df col dot t type means data type of column is equal to object, then we have to append that column name into obj list and print the column name, and df of column dot unique means give me the unique values of that inside that column, and also give me the length of that unique values. So if we run this command, we can see in our sscb column we have two unique values, that is others and central. hscb same others and central, which is true. And in degree t we have three unique values. One is science and technology, another is communication and management, and a third is others. So similar like this we have different unique values. And then now we will start with our you can say our visualization part. So first uh, let me import warnings, because I want to show my I want to create my notebook representable, or you can say I want to beautify my notebook so that I don't want any warnings. That's why I now type a command called warnings dot filter warnings, and this will ignore my all warnings. Now we are trying to draw a histogram with gender distribution. Here you can see we get our visualization. Now we are trying to create a pair plot for, let me check, am I audible or not? So, here unique. Yes, today I'm clearly audible. No issue. And so I'm trying to create a pair plot for uh, you can say float data type columns or numeric columns. Numeric columns when with the hue is equal to gender, means I want to split the data for gender 0 and for gender 1. It will take some time. Here you can see we get a beautiful diagram. So now we are trying to create a box plot of school, or you can say secondary school percentage. We can SSC P4 marketing and HR and marketing and finance specialization. Here you can say uh, uh, specialization with the finance have more you can say mean value or median value as compared to HR specialization. Let me again run this. Here we can delete this cell, and now we will again plot the let me copy this thing. Now we are creating box plot for box plot of HSC percentage. last time we do it for SSCP, and now we are doing it for HSCP again. And one more thing, uh, here I created a different data frame, that is MKHR data, in which I selected the data which has in my DF column, in my DF specialization column, which has market and HR, which I filtered as which I saved as MK HR data, and which has you can say finance in specialization. I save that data as MKT fine data, and we are concatenating both these data frame here for this data column, because we have to give our x-axis and y-axis and then data for books plot in SNS. Now again, now we are doing this for degree percentage. Let me run this again. Now we are doing for this. Test P. Now we are doing this for MBA percentage. So if you can see, in all scenarios, finance department specialization have more marks, or you can say more percentage in their secondary level, in high school, also in degree level, and also in e-test. Uh, Finance team scored more marks as compared to HR. Similarly in MBA. Also, you can see if okay, you can see which has so wait just a second. Let me run this and now give me that comment. Placement status distribution with gender. So if you can see, the uh, gender 0 got more placement as compared to gender 1. You can see also a huge gap in placement and not placed column. Here is huge gap. We can say gender 0 got more placements as compared to gender 1, and also for placement status distribution with work experience. Here we can also see there is a very much chances, if you have a work experience, you will get placement. Here you can see uh, which has a you can say work experience, prior work experience. They are around 65, and sorry, which has a prior work experience. 65 of them got placement, and 10 of them got unplaced, or you can say they do not get any placement. Now we are trying to draw a pie chart of specialization. We are trying to see how many people are in finance team and HR team. We can see there is 55.8% and 44.2% in HR department. Okay. So now we are creating salary distribution. And one more thing, sorry about it. I explained you this graph, but I do not explain you how I draw this graph. So I think this old graph you can make by yourself. But let me. So here we draw using SNS. SNS is our C1 library. SNS dot histplot. Histplot is for histogram, and we give our data as a DF, and our x-axis is equal to status, and hue is equal to gender. This is the, you can say, we split our data into two parts. That is, uh, uh, we split our data using gender column, or you can say filter our data. That's why we are getting two colors. One is for gender 0 and one is for gender 1. For title we use plt.title, and for giving x label like placed and not placed, for this placement status we use plt.x label. If you have to give here uh, any value, like instead of placed you want to give one value, then you have to use plt.xtick. For that we have plt.xtick. You have to use this command, but currently I'm not doing this. So similarly I create his plot again using here x-axis as status and work experience status as x-axis and work experience as hue. So for creating pie chart we need three values. uh, for giving the data we use this df of specialization dot value count. This will give me the value counts of, oh, this will give me the this value counts of finance and HR. Here we have to, and yeah, for labels we used same thing, but we type dot index. This will give me this value in an array format, dot index. Okay, and auto PCT is for this you can say how my percentage will look like dot one means there is 1 point after uh, uh, one digit after my decimal. Now we are created a new data from called place data. Here we shorted just take data which has a place status in their status column. And now we are creating a history plot, and here we give title, x label and y label, and plt dot show. KD is equal to true means we want to draw this line, or you can say smooth line. Bins is equal to means 20 means we want to split our data into 20 bins, like this one is a single bin. Similarly our second bin is this, so we want to create 20 bins. We want to split our data into 20 bins. Now we are creating we create a variable called calls with empty list, and we are running again a for loop call in df dot columns, and we are, if our data type is not object, then we are appending in calls dot append. We are appending in calls list. So this is we are performing for creating heat map, because a heat map will take only for correlation. For correlation, we can find correlation of just numeric variables, or you can say. So that's why we are sorting, or you can say filtering the columns which has numeric data type. So if I show you what's inside calls, you can see gender. My gender is in 0 and 1. Yes. SSCP, this is numerical variable. HSCP, degree P, E-test P, MBA P, this all are in numeric variable, numeric data frame, data type. So now we are creating correlation heat map of, or we can say correlation of, correlation in numeric variables. So for finding correlation, I will use df of columns. Using this command, I will get my data frame with just numeric columns. Here you can see I get this, and dot core is for finding correlation. Here you can see for, and for visualizing this in heat map, we use sns.heat map, and we give our data core, which we this is our correlation data which we saved in core variable, and give this core, and giving annotation, a note is equal to true. Like if we give this as false, then you can see there is no value, but we have. So now we are seeing these values. You can do it again. So now you can say we are doing a kind of one hot encoding. So my aim, I am creating a new column SSCB central, and in this column I am mapping my df SSC column B with where it is central, give me value as 1, and where it has value others, give me 0 value, or save 0 value in SSCB central column. Let me show you what I am trying to say. df.header. Here you can see we have our new column SSCB central. Like it has other, then it will give me value as 0. Let's see. Yes, it has 0 value. And if we have central value, then it will give us 1 value. Similarly, we are doing this for HSCB central. And in work experience, if I have a value as no, then it will give me 0. And if it has value yes, then I am mapping it to 1. And for using this, we have to use df of work experience dot map. We are using map method. Inside map method, we will give a dictionary, and we have none. For no, we have 0 value, and for yes, we have 1 value. Let me run this command. And for like status, if we have placed value, then we map it as 1, and if we have not placed value, then we are mapping it as 0. Now in space, now I am creating a new column called specialization fin, and I am trying to give value. I am trying to fill value using this df specialization. I am mapping the value marketing HR with 0 and marketing and finance with 1. So let me show you the data frame. If you can see, we have 3 new columns, or you can see we do a kind of one hot encoding for using these columns. So now you can see we can remove this column and this column, or you can say now we have converted these categorical columns into our numerical columns. So we are dropping these 3 columns using df.drop. Performing one port encoding for binary categorical, or you can say typical variables with 2 unique values. Now we are performing one hot encoding for this HSC stream and for degree T, because it has 3 unique values, and we have to give this in for performing one hot encoding. We will be using method of pandas library, that is dot get dummies, and we have to give our data here, and we are using drop first is equal to true. It will drop my first column, like this will create HSCS, give me 3 columns. One is for arts, one is for science, and another is for commerce. But if you can see, we can represent our arts column using science and commerce. What I am trying to say, like here is art, commerce, and science column. So if my art, well, we have art, then we can give this 0 and 0, and if we have commerce, we can give 0 0, and oh sorry, if it has commerce, then we have to give commerce as 1 and art and science as 0. But if we have science, we can give art as 0 and commerce also 0 and science as 1. But if we remove this, or you can say delete this column, commerce, delete this column, you can also see using that we can also find, yes, this is for art, this is for commerce, and if it get art and commerce column both get 0 value, it means it is of science stream. That's why we are dropping this first column, because if we train our model, it will give us a curse of dimensionality. That's why you using drop first is equal to true, and after that we are using s dot s type into int, because if we use just this will give me in true false statement. Here you can see this is giving me output as in true and false. For converting this into integer type, or you can say 0 and 1, we have to use as type as int. Let me run this. Now we are concatenating these 4 columns with these all numeric types, all numeric type columns. So for that I am using pd.concatenate We save this in a OHE variable. Okay, and for selecting uh, all numeric variables, we are grouping these two columns because all columns are in numerical variables and just these two are in categorical form. So that's why we are using df.drop with these two columns name and x is equal to 1. This is the, here you can see this all are just numerical variables and we are concatenating this data frame with our OH data frame with x is equal to 1 because we have to append this in a column form, not in row form. Here you can see this was our OHE data frame and this is our all numerical variables. So now we are finding correlation of features with target variables. Our target variables is salary and all others are feature variables. So this is giving us a visualization, but this is not in readable format. So what we are doing, we are finding correlated variables with respect to our target variable, that is salary. So what we are doing, so we save this correlation, you can say correlation value in core 1. Let me print core 1. Here you can see this is all correlation value. So I want to see this column with which variable has maximum correlation. So for that I will use df correlation 1 of salary. I have to find absolute value because if you know if it gives us a value, like for example a correlation value is minus 0.9, it means it is highly negative correlated, but we have to find highly correlated value. It we do not need we do not want it is a positive or negative. We find just absolute value. That's why we are using absolute, or you can say apps. Here you can see it will give me in a absolute. It removed all minus, and now we are sorting this. For sorting we will use sort values with descending order. So that's why we are using ascending is equal to false. So here you can see this is our target variable and this is our features with their correlation value with salary column. If you can see, status is very high correlated with our salary column, because if our placement is if our placement status is not placed, then its value is 0, and if our salary value is 0. Now we are saving this in a correlated variable name. So we save this in a correlated variable. Let me run this one. So now what we can do, we can select, if you can see these are very less correlated, you can say features with respect to salary, or you can say our target variable. We can drop these variables if we want, but we have to first discuss it with our domain expert, what will if these variables are important or not. If they are not important, we can drop this, and if they are important, then we cannot drop this. So now what we can do, we split our independent and dependent variables. Let's split our independent and independent variables. Dependent variables. X is equal to df of what my column name. So my column name is df. Oh, sorry, my data frame name is df1. So I have to use df1, and I am just dropping my you can say my target variable, which is salary. Salary, S is capital O, it is small. Salary with X is equal to 1 because it is a column. And now we are seeing X. Here you can see we have all independent variables. Similarly, we are doing for dependent variables. Dependent variables. For dependent variables, we have to we give a we are defining y is equal to df1 with column name as salary, because salary is our dependent variable, or you can say target variable. Let me see what's inside y. Yes, here you can see. Now what we can do, we can scale our independent variables. We can scale using this by we have two options. One is our min max scaler, and another is our you can say standard scaler. Standard scaler will give us distribution in, or you can say transformation into, with the mean value as 0 and standard deviation as 1, and in min max scaler we get our value from 0 to 1. So we will focus on, we will do we will use standard scaler performing normalization. So normalization is using a standard scaler, and standardization is min max scaling. So we are using before that I have to import my standard scaler. For that I have to use from scikit-learn dot pre-processing import. What I have to import, I have to import standard scaler. Let me initialize this scaler. Scaler is equal to standard scaler, and now what we can wait. Before that I have to perform train test split. I have to split my data into training set and testing set. Splitting data into training set and testing set. For that we will use a train test split. For the, first we have to import train test split. For that we have to use scikit-learn dot model selection import train test split. Yes, and then we have to define our variables xtrain, xtest, ytrain, ytest. Then we have to use the train test split, and we have to first give our you can say x value, and then after that y value, and then our test size. Test size will be 20%. 20% is for testing and 80% for training. For that we have to give 0.2, and then we are giving a random state. Random state means this will transform, or you can say split our data in same manner. How many times it do not affect how many times we want to split our data, or you can say running the same command. Yes, so there is no need to use stratify. Yes. Now let me see extract, and then I just a second. Let's put this, and now I will show you the difference, or you can say use of random state 10. If I run this one time, you can say this is 127, 47, 10, 6. This is my index. You can say this is my index number. But if I again run this command, you can say this I in my xtrain I have the same indexes. But if I delete this, you can say I am this time I got different indexes. Again, if I run this again, I got some another indexes. Here you can see I got another different indexes. If I want my data is same, then I have to use random set. We can use any value like 42. Like now this will 9384, and if I again run this, I will get the same indexes. You can see 9384. So now we get our x train, x test, y train, and y test. Now we can perform our normalization. So for scaling, we save our scale data in x trained scaled is equal to scalar dot. First we have to fit our train, or you can say for standard normalization, we have to fit our data. So that's why we are using fit underscore transform. This will take our extend data and first fit this scalar for extend data, and then transform this extend data and save this in extend scaled variable, and then we are using x test scaled. Now we are using dot transform. This time we are just using transform because my scalar variable is already scaled according to this extent, and just I want to transform my x test. That's why, and using this it will transform my x test using this scalar and save this in x test scalar. Let me run this one. So here, if I show you x train scaled, here you can see this is my scaled data. So what we can do, we can now fit our you can see we are fitting training our model, training the model. So first I am trying it with the, you can say, linear regression. For that we have to first import the linear regression using from scikit-learn dot linear model, import what linear regressor, and then we have to initialize this linear regression. For that, I am giving a variable called reg is equal to linear regressor, and then trying to fit this reg dot fit this on x train scaled comma y train, and then we are using reg dot score for scoring our model using x test scaled and x oh sorry y test. So this what it will do, it will first fit our model using x train scaled and y train, and then for we are using score, it will predict value for x test scaled and then compare it with y test and find the error. So we are getting 72% of accuracy with this model. We can hypertune this model, but we can use different models for that. So I have multiple algorithms, like for we are using I have saved many algorithms in a notebook, so that's why I'm copying the all algorithms, or we can say names of algorithm. Just let me run this, and then I will explain you what is this going on here. One more thing. I have to again transform my data. X, you can x into x scale is equal to scalar dot transform this data in this x into x scaled, and then we type x scale. So here what we are doing, we are using multiple algorithms and finding the best hyperparameter, and you can say best model with best hyperparameter for our uh, problem. Here you can see we got the score with the region. We are getting 71% accuracy. With lasso we are getting 71.7% accuracy. With linear regression we are getting 71.7640 accuracy. So let me so these all are we are importing the libraries, and here we go. Here we defined a dictionary called algos. Inside this dictionary we have this one complete key value pair. Here this linear regression is key, and it has a dictionary as value, and inside this dictionary uh, we have a model as key and linear regression as value, and uh, params as another key, with values as empty dictionary. Similarly in lasso, like we have another key of algos variable, or you can say algos dictionary. We have another variable called lasso, uh, and lasso has a value as a dictionary, uh, and inside this dictionary it has a value of a model. Oh, sorry, it has key of model with name model, and model key has a value with lasso, and inside params we have alpha and uh, params, you can say params key has a value as a dictionary type, and inside this dictionary we have our hyperparameters, that is in alpha with two possible values. It can be 1 or 2, and with the selection it can be random or cyclic. Ridge with maximum iteration, it is around 1 lakh. Yes, it is 1 lakh. And params alpha is equal to a possible value for alpha is 1 comma 2. We can do one more thing. If you can see here, we are getting similar score as compared to lasso and ridge, but there is no elastic net algorithm. So elastic net algorithm, what elastic net algorithm do, it combines lasso and ridge model, so we can use both these model in a single model. Let me try it for this. From scikit-learn dot linear model, import elastic net, then again initialize it, drag for, or you can see e net is equal to elastic net, then again training e net for x train scaled comma y train e net dot score. Score is for finding accuracy score, x test scaled comma y test. No, we are getting bad results, so we will use our ridge for that. So we have done. Now what we have done, we have we have transformed our complete x. Here you can see, sorry, we have transformed our complete x, not just x train, because in this here we are using grid search CV, and grid search CV what we have, we take multiple, you can say we split, just a second, let me show you grid search CV. Here you can see, yes, here you can see. Here, if how can I zoom this? So what we do in grid search CV, we take our complete data set and split into like how many fold, we split into folds, like in this case, complete data set and split into like how many fold, we split into folds, like in this case, yes, so let me continue. So I'm what I'm saying, For in grid search CV, we take our complete data set and convert that into 10 and split that into 10 folds, or you can say 10 parts, as you can see here. And we take 9 folds for training and 1 fold for testing. Similarly, in second iteration, or you can say second round, we take again 9 folds, but we take different, you can say different fold for testing. Like in this case, we take this fold for testing, but in next case we take this fold for testing, and for in third iteration we take this fold for testing, and in fourth we will take this fold, and so on. And then we test for second hyperparameter, and again we you can say we again take 10 different iterations, and up to n hyperparameters. Then we will then we say we take all average of first, you can say first, if we have 10, we split it into 10 folds, then we get 10 iterations. Then we take average score of these 10 iterations, and for hyper parameter, second hyperparameter, we take average of this 10 average score of this 10 iterations, and then we find which hyperparameter, you can say, giving us maximum score, and then we will take that hyperparameter. So this, we will take that hyperparameter. So this, let me open my notebook. Here you can see we have used just grid search CV. We splitted our data into 5 split, and we take 80% as our testing set, and sorry, 80% as our training set, and testing as 20%. Here you can see. Now we can delete this if we want, or we can, let's we do not delete this, and we will work on linear regression or ridge regression. We can also work on ridge regression. Let's see how this will work. Let me take ridge. We can for cross validation we can also use ridge CV. If you can see from scikit-learn dot linear models, linear model import ridge, we have also ridge CV. Ridge CV with built-in cross validation. Let's try to run this. Let me define reg, or you can say reg1 or ridge. Let me save it as ridge CV. Ridge CV. So here ridge regression with built-in cross validation. Let me see. Default it will take 0. First it will try for 0.1, and then it will for 1, and then, or still like of shape. I think yes, I think this will take 3 cases, or let me do one thing. Let Google it. Ridge CV skill. Array of alpha values to try. Yes, here you can see it will take four. You can say it will score uh, take four different alpha values, or you can say it will train for uh, multiple alpha values, like for this alpha value, and then it will train for this alpha value, and then for this, and then for this. Okay, let's try this. I am giving the default value, so ridge cv dot fit on x train scale y train ridge cv dot score x test scaled y test. Here you can see our accuracy score is increased, so we can hyper for alpha finding the alpha value, which alpha value is it is using, we can use ridge cv dot alpha. Here you can see it is giving value for 1, and here it is given for 1, but we can see what other different parameter it has, hyperparameter it has. We can use coefficient, I guess. No, this is something different. CV values, get params. Using this, we get a bound method. How to open this? We can use ChatGPT for that. How to see? We can use print for this value. Like how to find hyperparameters for ridge CV. No, this is, we can use best estimator. Okay, okay, okay. Let's try with best estimator. Ridge CV dot best. No, this it has just the best score. What we can do, feature name and feature intercept score. So we do not have uh, uh, we cannot find for another hyperparameter. Oh, so this score is for complete x, not for x train. Here you can see we give our complete x. Now I get it. Okay, okay. Just let me do one more. Now we will train ridge for our x train, and then we predict our x test. Cool. Here from we get so So now what I am doing, I am importing my ridge regressor, and here I am giving alpha value as 1, alpha as 1, and fitting it for x trained, scaled, and y trained, and then finding the score ridge dot score for x test scaled, comma x, oh sorry, y test. Here you can see we get around 72%. That's nice. So now what we can do, we can predict it for our test.csv value. Before that, we will do one more thing. We will save our data, or you can say we will save our model inside a pickle file, and also scalar, because while if we create a web app, there we need scalar and model for finding predictions. Let me do one thing. So for finding the, or you can say for saving our pickle file, we have this command. Let me first import my pickle file, or sorry, pickle module, pickle library, import pickle, and for saving this ridge, we have this command with open. How we want to save, like I want to save it as model.pickle as f, and then pickle.dump. What's our model name? It is ridge, and then run. You can see here I got my pickle file, or you can say saved model. Now what we can do, let we can do saving our model. Now saving our scalar. For that we have to use same thing, just here type scalar, and what's our scalar name? It is nothing but scalar. If we run here, you can see we got our scalar also. Now what we can do, first we will you can say give comment the complete. Let me give me name, finding best model. Training ridge model. Now we will import test.csv file, and then do the complete transformation as we did it for you can say train.csv, and then try to predict it for try to predict this using this ridge model. So importing test.csv file. For that I will save this in a test and then df dot get csv. Oh, sorry, not df, pd dot read csv, and then our file name is test.csv, test.head. What we can do, let me copy this test data frame into another data frame, test dot, or you can say test1 dot copy, sorry, test dot copy, and save this in test1 variable. And now we will work on our test1 and remain it. Wait, why there is just 3 columns in test.csv? There is just 3 columns. Let me see the cabin link. So the data files here, you find the file. In test.csv we have 3 values. If there is salary is already given, then what we have to predict? We have to predict salary for IDs. Let's see. I'm not getting the problem. What we have to predict. So test have, let me import train pd dot read csv, train dot head. Here we have serial number, but we can do train serial number dot unique. So we have from 1 to 215. Now let's see for test 1 serial number dot unique. Are they similar to? So you can see we have 123. Here we have 123. Okay. So let me see is other columns are also similar for this. For test 1 salary, oh sorry, serial number is equal to is equal, just do this in the next is equal to 123. It's in a string format, so we have to give this in string format. Let's see what we get. Into, not into, test one. And if this, here we can see. Now similarly we do it for train SL serial number is equal to 123. So if we get yes, we get the same salary. Gender is equal to 1. Yes. Okay. So what we have to okay. So test one has same value as salary and gender as serial number. So it is possible that this is for validation. We can do one more thing also. If we take serial number as our you can say feature, then it will predict it for but let's forget it and head towards our creating web app for this. Forget this. We get our 72% accuracy score. Let's try to implement this one. You can say web app or Flask web app. Let's save this notebook, and now let me copy the sample Flask app. So I have created a sample Flask app which I will copy on this directory, that is campus recruitment prediction. Also app.py, copy this complete, paste it here. Now we will you can say we will work on this Flask app. We imported Flask user from Flask. We imported Flask render template request redirect. I guess we do not need redirect. We can remove this. We need URL for no. Also we do not need URL. Cool. Yes, we need we need numpy, we need request, we need pickle. Pickle is for importing or loading our model and scalar. Here we loaded that. Here pickle dot load open model dot pkl, and same for scalar. Now this is our home page, that is index.html. This will change in this we will change in some time. Okay, now this is for submit. So now let's change our index.html. Then we will change it for our class cap. So our title is campus recruitment prediction. Prediction. Let me delete this style. We can style our HTML using ChatGPT. That's why I removed that style, because I have to fill or you can say add multiple fields in this HTML page. That's why. So our first field is, what's our first field? Let's see. So we do not take we do not need a serial number. We need gender. For gender we take this value, because this has option. Let me paste it here. Instead of item fact content, it is gender. 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 So we are giving 0 is for female and 1 is for male. So we are giving value for female 0 and for male 1. Okay, this is done. Now we have to move forward for SSCP. With this SSCP. We can say percentage in SSC, secondary school. Percentage in secondary school. Or we can just type SSCP. Here type is string. We will take it as string, and then we will convert this into our float value when we load it for our app. We can do one more thing. Possible input types in HTML. Let's see. We have text, password, email, number, date of birth, checkbox, radio, file, or button. Input type for float value in HTML because our marks will be in float value. That's why I'm using this. So we have to use function type text. Here you can see. So we'll take it as just a string. Then we will convert this into here we will convert this into float type. No worries. Again, what's next? What's our next field? It is okay. It is board. So we have two options for that. So we will copy the gender part and convert edit in this part. Copy this and paste it here. Instead of gender, we have SSCB. So we have two values. One is others, or one is central. Other. Let's see. Yes, we have others and central. We are giving the same value. C is capital or not? Let's see. Yes, C is capital. We can do one more thing. We can directly do one hot encoding here, or we cannot do. But yes, we can do. If you can see in our notebook, in our X, what we have. Let me see for X. So in X, we have for SSP central, it is 0. Okay. Means for central it will be 1 and okay. For central it will be 1 and for others it will be 0. And then we will map SSP to SSB central. Okay. Cool. Now what can we SSL just a second. So we done for SSCP, SSCB. Now we come to HSC, SC. Let's see. We can copy and paste this. We have to take care of indentation. Here you can see. Now we will do it for H, S. So it's, I guess, in one encoding. There is also central. Yes, it also is central. Okay. central, and then we do it for HSC stream. Okay, copy this thing. Now we will create three options. Let me create third option, and now we'll give a same value, like we do not give a 0001 like that. It is HSCS. Let me cross check. Yes, HSCS. So there is three unique value. Let me see what it is. One is commerce. Another is art science. Third one is art. Okay. Here, copy the same thing for value. Copy same thing for value. Copy same thing for value. Now we do it for degree P. Degree P we can copy this thing because this is for values. We have to do it for degree P. No? Degree P. Now we have to do it for degree T. What? How many unique value degree T has? Let's check. It has three unique values. So we have to create three buttons, or you can say three options. Cool. Let me copy the same thing. Paste it here. This is degree S, I guess, or degree T. It is degree T. Degree T. Degree T, and what are values? What are possible values? One is science and technology. Copy this thing and paste it here. Then another is communication and management. Oh, I don't include right paste it. And our third option is others. Again, we have to copy this thing and save it here, paste it here. copy this thing and paste it here. Copy this thing and paste it here. Now we have to do it for work experience. So as we map 0 value for no and 1 value for y, yes, we do same thing here. Let me copy this field. This is not copying in similar indentation. So we have to do it for work experience, I guess. Yes. Work X. Work X. Work X. And for yes, my value is 1, and for no, my value is 0. Cool. Now we have to give float value for e test p. We can copy degree p and then edit this. Sorry. We have e test p. Test p. Okay, we do it for now. We have specialization part. I guess specialization have two categories, and we do one also mapping for this. Let me cross check it. For specialization, yes, for we give finance. For finance it is 1, and for marketing it is 0. Oh sorry, for HR it is 0, and for finance it is 1. Okay. So for what's the column name? It is specialization. Okay. We have for HR it is 0. For HR it is 0. And for finance it is 1. Cool. Now we have to do what we have to do. We have to do it for MBAP. We will select e-test P and then edit this. MBAP. Paste. Now status. I guess for status we also do one hotel code. I think for place we mapped it to, with one. Yes, here you can see status one. Let me see where I mapped this. Here you can see for place I mapped it to with one. I forgot to close this. Yes, I forget to close this div here. Here also. Here also. Let me do one more thing. Let me just select this and this thing and do this thing. Here it is complete, and for place it is one placed, and for not placed it is zero. It is status. 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 And we have to copy this thing also and do this here. Here it is open, close, open, but not close here. So we have to close this thing. Here it is open, but we forgot to close. Here we have to close. Here also we need to close. Here also we need to close. And here also we need to close. Yes. Now we can delete this complete code because this is not useful for us. So there is a submit button. Okay. We can do one more thing. This is not looking nice. We can capitalize this. Instead of MBA we can say MBA marks. MBA marks. Here capitalize as nothing. Here it is degree. Oh, I forgot to degree. We can say degree score instead of MBA score. We can MBA score. Oh, E-test score. I'm sorry. E-test score. Work experience. Degree trade, or we can say degree stream. Degree score. High school stream. high school board. Secondary school score. Wait, it is high school score, and it will be secondary school board. Secondary school score. Legend. Okay, so we can save this. Yes, we can save this. Now we have to import, or you can say load our values from index.html. Erase this complete thing. You can say, let's erase this. So first we have to take value for gender. Or we take our value in form of in this form. Let's see. In this sequence, we take our values in this sequence. First we have to take it for gender. Gender is equal to, gender will be int request dot form, whatever form is, it is gender. Nice. Then we have to take value for our SSCP. It will be in for float value. Okay. SSCP is equal to, it will be in float data type request dot form, that is in SSCP. Similarly, but we can do one more thing. Just copy this multiple times, because this SSC board and SSC, you can see central. Yes, we can do this, and we have to convert our values into int type. We can copy this entire thing out, paste it here. Instead of h, we have to, instead of s, we have to just replace it with h. Replace it with h. Okay. Now what's our next value? It is high school stream. Cool. HSCS is equal to, no, this we do not want to in float value. HSC underscore S. I think this is the ID. HSCS, yes, HSCS. Now we create an if else condition.